Okay, we want to talk about solving rational equations. I just want to remind you what we've been doing for the last few days is rational expressions. There's been no equal sign. We're just sort of performing an addition, a multiplication, we're simplifying. But now we're actually trying to solve something. So we're coming up with values of x that make the equation true. So the left side equals the right side. So we're definitely going to have these equal signs. But let me show you what we're not doing, what's not a rational equation. It's still an equation. So we'll say you had x plus 1/2 is equal to 2/3. Yes, I see fractions, but you don't see x in the denominators. So this is actually not what we're talking about, okay? This is the old-fashioned x would just equal 2/3 minus 1/2, and everything's honky-dory, except I didn't have a common denominator. So, you know, I need the 6's as my common. So 4/6 minus 3/6. X is equal to 1/6, okay? So this is, again, not a rational equation. So I don't want you to overgeneralize just because you see a fraction that this is what you do. Alright, so let's do an example of what we really do mean. Okay, so here is a real rational equation. And you'll notice I've got x in the denominators, and if I think about this, and if I wanted to add them together, I would be thinking about least common denominators. Okay. So here's the deal, though. I don't really want to add them together. I just want to solve this thing. And it turns out that there's a technique that's related, but actually works out better for us in the long run. So you still need, though, to find what would the least common denominator be. So we'll need to factor it. So let's go ahead and factor this x plus 3 and x minus 3, of course. So if you were to find the common denom, it would have been x minus 3 times x plus 3, okay? But what we're going to do with it is something a little different. And before, when we didn't have the equal sign, we just had expressions, we had to go top and bottom by, you know, the sort of missing factor. But now I'm going to take the entire common denominator, multiply both sides by this. So instead of going to top and a bottom, I'm going to go a left and a right and multiply both sides by all of the common denominator. Okay, so let's see what happens when I do that. So I'm going to have x minus 3 times x plus 3 times the whole thing, x over x minus 3 plus x over x plus 3 on the left, and on the right 2 over x plus 3 x minus 3 times x minus 3 x plus 3. So I've multiplied the left side and I've multiplied the right side. Now over on the right side it's pretty simple. I'm going to make sure I cancel any common factors, okay? And you see the beauty of this method right there is I no longer have a fraction. I'm just left with 2, okay? And then, you know, if I wanted to remember my lost domains, I would say x cannot equal 3 or negative 3. But what's going on over on the left-hand side is I have to remember that when I multiply, I have this distribution because of the plus sign. So I have to remember to multiply both of these to the first term, and then both of those to the second term. So I'm going to spell it out for you. X minus 3, x plus 3, times x over x minus 3, plus, I have to distribute the x minus 3, x plus 3, times the x over x plus 3. And what happens is now I'm going to start to cancel each one of these. So in this first fraction, the x minus 3's cancel, and in the second fraction, the x plus 3's cancel. So I'm left with, I'm going to wish I'd left more room, I'm left with this term here, x times x plus 3, plus, the only thing left in this other one is x minus 3 is equal to 2. Okay? And again, the beauty of this method is I don't have a fraction anymore. They're gone. The denominators are gone. Canceled them right on out. So let's go ahead and solve this now. The old-fashioned way, I'm going to distribute before I can add those two terms together, x squared plus 3x plus x squared minus 3x is equal to 2. Remember, this is going to be a quadratic. I need to gather all my like terms and set it equal to 0. So I have 2x squared. The minus 3x and the plus 3x actually add together to give me 0. So it's like they cancel. I hate to use that same word when we're talking about this section. So let's just say I added them together and they made 0. I've already added my x squares together, so 2x squared is equal to 2. And I think you can see where, let me go up here, I got a little bit of room left. Divide both sides by 2, x squared is equal to 1. So x is equal to plus or minus 1. And that would be my solution. I have to be very careful in this type of problem that I haven't upset the domains. Okay, remember, x was not allowed to equal 3 or negative 3. So, okay, I'm okay here. I haven't, contradicted the domain. Alright, if you think you got it, you can go ahead and try this one. I'm going to go ahead and solve it as well, though, because this is going to take a little repetition. So let me try it one more time on this problem. I want to make sure I'm factoring it, so I would find what would have been the least common denominator. So let me show this one factors as x plus 2, x plus 1. So my LCD would have been x plus 2 times x plus 1. And I'm going to do that on both sides of my equation. So I'm going to distribute it to this left side, both terms, and I'll distribute it to the right-hand side as well. Okay? So I'm really multiplying both sides of the equation. So let me write it out. I've got the x plus 2, x plus 1, times the first term, x minus 1, over x plus 2, x plus 1. And then I have to add, the next term gets multiplied by that same x plus 2, x plus 1. So here's the second term, 2x over x plus 2. And that's going to equal, I need to multiply by x plus 2, x plus 1, times the right-hand side was x minus 1 over x plus 1. Alright, so let's look at what can cancel in each individual piece of this. So in this left fraction, this left term, the x plus 1's cancel, the x plus 2's cancel, and you should always find that the denominators both cancel. Or always, everything in the denominator should cancel. So that leaves me with x minus 1. It also leaves me with x cannot equal a negative 2, x cannot equal negative 1. So keep those in mind, okay? Alright, then I have the second term where the x plus 2 cancels the x plus 2, leaving me with 2x times x plus 1. Okay? And then over here, on the right-hand side of the equation, the x plus 1 cancels the x plus 1, leaves me with the x plus 2 times the x minus 1. Alright, so now it's a matter of distributing, so I can add like terms and solve for x. So, let's just keep this x minus 1, plus 2x squared, alright, I've got a quadratic, plus 2x is equal to, oh, don't forget to FOIL this, x squared plus 2x minus 1x is a plus x. I've combined those like terms because I'm pretty good at doing that when I'm multiplying two binomials, and then minus 2. Alright, let's gather up like terms. If I took this 2x squared minus that x squared, I have 1x squared on the left. This x here plus 2x is 3x minus this x. What did I say? I had 3x minus another x, so I have 2x. I have a minus 1 here, looking for like terms, and I'm going to add 2 to that, so I end up with plus 1 is equal to 0. Alright, so be careful. Do it carefully and as in the method you like. but I'm going to see if I can solve this. It sure would be nice if it factored. X minus 1, x minus 1. It does factor. That leaves me with a solution. I'm running out of room, but x equal 1 is my solution. It's a repeated root. Remember we talked about having multiplicities. So there's a multiplicity of 2. It's a repeated root, x equal 1, that does not contradict the lost domains, so it's okay. If you do find the contradiction, remember that's what we would call an extraneous solution, okay? One that appeared to be correct in every way, except it really wouldn't work. All right, I want you guys to go ahead and try this problem on your own. It's a simpler one than what we've been doing, so you're not going to have these binomials and things like that. So find that common denominator, multiply both sides by it.